So let's say we have a marginal profit function that looks like this: 100 e to the t minus 100 plus 0.2t. And what we want to do is find total profit and average profit over a certain time period. And let's suppose t profit, p, is in dollars and t is in terms of days. And let's say we want to figure this out for the first 10 days. So the company is operating. So what we're going to do is find the integral of marginal cost, or the integral of 100 minus 100 plus 0.2t, and we'll get 100 e to the t minus 100 t plus 0.1 t squared, evaluated between 0 and 10. We can check just to make sure we've got the antiderivative correct. So integral antiderivative of e to the t is just e to the t. 100, the derivative is negative 100 for negative 100t, and 2 times 0.1 is 0.2 times t. And this is going to equal 100 e to the 10th minus 100 times 10 plus 0.1 times 10 squared minus 100 e to the 100th minus 100 times 0 plus 0.1 times 0 squared. Which is going to give us, I'll do the math for you. These all cancel with the zeros, and you're left with $2,201,556.58. Not bad for 10 days' work. Now, to find the average, what we're going to do is simply divide by the 10 days. So the average for the 10 days is going to be 220,155.66, rounding it, per day. That's the profit. So the total profit was this we found using the integral. The average is that value right here, divided by the time frame. In general, all we're doing when we find an average value of a function we're simply taking the integral over that the integral over the interval, excuse me. So taking the integral over an interval, dividing it by the size of that interval. So let's take another example. So let's say the population of the US can be modeled by the equation 282.3 times e to the 0.01t where the population P is in millions and T is the number of years since 2000. So in the year 2000, there were 282.3 million people in the US. And what we want to do is find the average population between 2001 and 2005. So all we're going to do is we're finding the integral, definite integral over particular interval from year 1 to year 5, or from 2001 to 2005. And that will give us the total population over those years. And we simply divide by the time frame of the 4 years. So what we'll get is on top we have the integral, or we take the antiderivative, and we get 282.30 e to the 0.01 t evaluated between 1 and 5. And to test this, make sure we've got the correct derivative. So if we have 282.30 times e to the 0.01 t, the derivative using chain rule would be 282.30 e to the 0.01 t times the derivative. This is e to the u. So the derivative is e to the u times du, or the derivative of 0.01 t. And that gives us our 282.3. So we've got this correct. And now, evaluating, we have 282.30 e to the 0.05 minus 282.30 e to the 0.01, which equals 1163.7 roughly. And we'll take that and divide by 4, which gives us 290.9, or the average population over that 4-year span was 290.9 million.